Welcome to this overview of the option scenario spreadsheet I prepared using Python and xlSlim. All the Python code and the Excel file are available to download from GitHub. I've put the link in the description below. We start by registering the Python module as usual using the register py module function. This adds all the functions to Excel, and it also creates a function for each class in the Python module. The spreadsheet was prepared in October 2022, so all the data is correct as of the 7th of October 2022. The first section is the market data section. Here we input our index levels, our cost of carry or dividend yield, as well as our volatilities. The volatility modeling is the area where I made the greatest simplifications. I only cater for 1 vol per expiry. Of course, in practice you would have a volatility surface with strike and expiry dimensions, and often sophisticated techniques are used for interpolation and extrapolation. However, I needed to keep the code size manageable. Next we input the risk-free rate, and finally we input the option multipliers. These multipliers are for CBOE equity index options. The spreadsheet has the ability to tweak market data. We can tweak spot levels and volatility levels. Spots are tweaked in percentage terms, and vols are tweaked in absolute terms. If we adjust our spot levels to be 105%, the spot levels are multiplied by 105%, so the S&P level goes up to 3,900 and the Russell goes up to 1,800. Similarly, if we adjust down to 95%, the S&P goes down to 3,500 and the Russell goes down to 1,600. Vol tweaks are added to the vol levels, so if I add 10%, you'll see that 10% is added to the volatilities. Similarly, if I subtract 5%, you'll see that 5% is deducted from the vol levels. Now that we have market data, we are ready to enter some options. I will enter a Condor Spread position. I've put a link in the description to an excellent Investopedia article which describes the rationale behind a Condor Spread. We start by entering a long put position, strike 36.50. Then we put in a short put position at 3,700. We go short again at 3,750. And finally we go long at strike 3,800. We can see that the portfolio PV and risks have been calculated. There is a toggle that will control whether the details are shown per option line as well. Normally we would leave this disabled for optimal calculation speed. If we go back and tweak the market data, you can see the calculations adjust accordingly. I adjust my spot levels by 10%. And we can also adjust the vol levels down 5%. Let's switch off the detailed view and have a look at some portfolio stress testing. There is a toggle to enable or disable the stress testing. Behind the scenes, this was done using Excel's data table functionality. In the documentation I give a full description. We can also choose which risk metric to display. And as you can see, the data table updates accordingly. Further down the spreadsheet we have some graphs. And these graphs show the effects of the spot and vol tweaks on the chosen risk metric. We can see that the Condor Spread has very low vega sensitivity. However, the gamma sensitivity is much higher. If we scroll back up to the top of the spreadsheet, we can adjust the as of date to be the same as our option expiry date of 16 December. Scrolling back to the stress testing section, if we choose to display PV, we can then view the traditional hockey stick graphs of option payoffs as often shown in finance textbooks. This is also a great way to verify that we've entered our portfolio correctly and that our option strategy has the payoff we expect. I do hope you found this video interesting. The spreadsheet is reasonably close to what is done in practice and is a nice showcase for xlSlim's abilities. I have written a comprehensive document describing how I implemented the spreadsheet using both Excel and xlSlim functionality. Thank you for watching.